Welcome to Public Health on Call, a podcast from the Johns Hopkins Bloomberg School of Public Health, where we bring evidence, experience, and perspective to make sense of today's leading health challenges. If you have questions or ideas for us, please send an email to publichealthquestion@jhu.edu. That's publichealthquestion@jhu.edu for future podcast episodes.
This is Lindsay Smith-Rogers. Today, the hidden threat to the human race from fungi. Dr. Arturo Casadeval, an infectious disease specialist and chair of the Department of Molecular Microbiology and Immunology at the Johns Hopkins Bloomberg School of Public Health, talks with Dr. Josh Sharfstein about his new book entitled, What If Fungi Win? Let's listen.
Dr. Arturo Casadeval, thank you so much for joining me again today on Public Health on Call, this time to talk about your new book, which is called What If Fungi Win? You've written this book with Stephanie Desmond, one of the hosts of Public Health on Call. And when I picked it up, my eyes were really drawn to this sentence: of the many ways to die that we're actively afraid of, nuclear war, viruses, bacteria, parasites, cancer, and violent crime, to name a few, one assassin that doesn't usually cross our minds is killer fungi. And when I was done reading that sentence, I thought, that assassin has now crossed my mind, and I want to learn more about it. Before we get into all the ways that fungi can kill us, could you maybe remind me and our listeners what a fungus is?
So a fungus is a class of organisms. A fungus includes mushrooms. A fungus also includes yeast that you use to make bread and beer. So they are related. One of them is microscopic, yeast. The other one, you can see it, a fungus. They are a vast class of organisms. They are enormous, millions of species. They happen to be our closest relatives in the biosphere. They are a lot closer to us than plants are, for example. They are closer to us than protozoa are. But if you think about them, they have their cells like we do. They have a nucleus, and they are very similar biochemically to animals.
I was impressed and very much surprised to read that the largest organism on Earth is a fungus.
That's right. And this is out in the Midwest, an enormous organism. And it's a single organism that basically grows by extension. So it occupies a lot of land. And how do we know it's the same organism? Because if you sample one piece and then you walk the other side of this region, and you sample another one, you see that they're the same genetically.
And when you say this region, you're not talking about like a little vegetable plot here.
No, we're talking about hectares.
Yeah. So before we get to the different ways fungi can kill us, could you tell us some good things about fungi?
Absolutely. So life on Earth, as we know it, would not be possible without fungi. They are the big recyclers. When a tree falls in the forest and has to, all that carbon and all that nitrogen needs to go back into the biosphere, it is the fungi that break up a lot of that stuff. And they do so. They are remarkable in the types of metabolites or compounds that they make. For example, penicillin is made by a fungus. People who are taking drugs for cholesterol, the statins, are made by fungi. And obviously, many of us who enjoy wine and beer, that would not be possible without the fungi.
You're making a pretty good defense of fungi. What about the psychedelic properties?
Well, as you know, that some of the mushrooms can give visions. They are, in fact, used, and there is increasing work of using them medically. But another very important compound made by a fungus is LSD. LSD is a fungal compound. And that raises, to me, a very interesting question to think about the cool of the evening. Why are these fungus making things that make people hallucinate? And I'll be frank, I don't know.
Let's move to the prosecution. Why should we be worried about fungi? What is the risk to humanity?
So, Josh, if you had come to Hopkins Hospital 100 years ago, you would not have found it would have been fungal diseases. Maybe you would have found a rare case of it, but generally they simply were not there. We have tremendous resistance to fungal diseases unless we become immunosuppressed. And when people become immunosuppressed, they become susceptible to them. And our medicine, the great progress that we have made in medicine in the last century, is often at the price of immunity. Think about transplantation, think about cancer, think about the treatment of autoimmune diseases. Anytime you affect the immune system, you increase the risk of fungal diseases. So fungal diseases are increasing every year. They're increasing as a result of medical progress. They're also increasing about other consequences. For example, the HIV pandemic, which was heavily immunosuppressive, brought a lot of fungal diseases. The medical problem of the fungi is getting worse each year.
Could you give some specific examples of fungal diseases that are in your mind when you say that?
So let's take an organism like Cryptococcus nymphormans. It was only described at the beginning of the 20th century in a rare case in Germany. By 1950, there were maybe 500 cases in the entire world literature. By 1990, we documented that it was the most common meningitis in New York City, with about 1,200 cases. And that reflected the large numbers of individuals living with AIDS. And the problem with this kind of infections is they're very hard to treat. And a lot of them, unfortunately, are associated with high mortality and morbidity. So that gives you a sense, a snapshot of the 20th century.
Right. Other than cryptococcal meningitis, other conditions?
Aspergillus. Mm-hmm. Aspergillus is a very common pathogen for individuals who are immunosuppressed. It's very hard to treat. People who live in the southwest of the United States and California are exposed to coccidiomycosis. This is a fungus that lives in the soil. Again, when people are immunosuppressed, they can get very serious disease. In the Ohio River Valley, you have histoplasmosis caused by Histoplasma capsulatum. Around the Great Lake areas, you have blastomyces dermatitis. And as you move around, what you see is that different regions often have different fungi that cause disease.
I recall the outbreak of fungal meningitis that was caused by contamination of compounded medications. Often it was a steroid, which is immunosuppressive, and there was a fungus inside, and then people got these horrible conditions.
Right. So the air that we breathe every day is full of fungal spores, period. You breathe them in and you breathe them out. And most people don't get disease. Their immune system can deal with it. What happened in that situation was there was a breakdown in the sterility of the formulation. So they were not making anything related to the fungus. They were basically making steroids for treating individuals with back pain and other conditions. And these fungal spores got in it. And then when they injected the steroids, they injected the fungal spores. And think about the situation. You're not only putting fungal spores directly into tissue, but you're putting it with an immunosuppressive agent. It was catastrophic for those individuals who were affected. This is a very hard to treat fungus, and it led to even a criminal investigation.
You mentioned that fungal infections are hard to treat. Why is that?
That is a very good question. And what I'm going to say to you is largely speculative, because I think most people don't know the answer to that. But let's just take a typical bacterial infection. Let's begin with something like pneumococcal pneumonia, which is relatively common. You can treat it with antibiotics, 7 days, 10 days, and the individual's recovered and without any consequences. Let's take a fungal disease. Let's take histoplasmosis, coccidiomycosis. Now you have to treat for many months.
Months,
and with complicated regimens. When you stop the therapy, there is a significant likelihood of recurrence, of relapse. Why are we able to eradicate the bacteria better than the fungus? It could be that the bacterial drugs are better. That is, the penicillins, the cephalosporins, the things that we use are just better at killing the bacteria. But it is also possible that the fungi, these organisms live in the soil, generate a lot of diversity when they're in tissue. So you tend to get a lot of fungal cells. And killing the last one of them is just very difficult. So it could be a combination of things. It could be that our drugs are not great. And two, that once the fungus gets into people, it's because they're immunosuppressed. And it's very hard to clear an infection with drugs alone.
To what extent is resistance to the medications that we have a big problem?
So resistance is an increasing problem for some. Now, organisms that you get from the environment don't tend to be resistant, except in one case that I'm about to cover. But organisms that are exposed to antifungals all the time, for example, Candida albicans, some of the organisms that we see in the hospitals are increasingly resistant. So we don't often test for resistance. So what happens is the patient is put on antifungal drugs and doesn't recover as fast as we want, and then you test it, and then you may find that the organism is resistant. Let me give you the exception. It's Aspergillus. So in the Netherlands, and we cover this in the book, in the Netherlands, a class of antifungals known as azoles are often used in agriculture. And what people began to realize was that the patients were getting infected with azole resistance strains. And what was probably happening is when farmers and people who care about in agriculture try to treat their crops for fungal diseases, they were inadvertently creating resistance in Aspergillus. Aspergillus was not the target, but it was the problem then for the people who got infected.
Right. And I hear your message in this book is pay attention. Pay attention to fungi, because don't have an out of sight, out of mind attitude because of these consequences that can be incredibly serious for health. Now that I have this firmly in mind and I'm not overlooking fungi, what can we do, Dr. Casadevall?
I think the most important thing is what you said. We need to have increasing awareness. And that extends all across the spectrum of society. Physicians, for example, often don't necessarily think of fungal disease. Fungal disease it can often be diagnosed late because they weren't necessarily thinking about it. You got to think about a disease to look for it. In that case, we need awareness on healthcare providers. We need awareness on the public. And the simple, most important thing that humanity can do to prepare itself against the fungal threat is to carry out research in this organism. We need to know what's out there. Most of the planet hasn't been mapped. We don't even know the numbers of species. They're decimating entire ecosystems, and we just don't know very much about it.
Well, I think whatever I'm worrying about on a particular day, I will try to distract myself by thinking about fungi now. The picture you painted is very serious. Fortunately, we do have some treatments for people, but the time is now to pay more attention, and your book really drives that message home. So thank you so much for joining me. Thanks for doing this book.
Josh, thank you for talking to me about the book.
Public Health on Call is a podcast from the Johns Hopkins Bloomberg School of Public Health, produced by Joshua Sharfstein, Lindsay Smith-Rogers, Stephanie Desmond, and Grace Ceciri. Audio production by J.B. Arbogast, Holly Cardinale, Spencer Greer, Matthew Martin, and Philip Porter, with support from Chip Hickey. Distribution by Nick Moran. Production support from Catherine Ricardo. Social media run by Grace Ceciri and Eliza Rosen. If you have questions or ideas for us, please send an email to publichealthquestion@jhu.edu. That's publichealthquestion@jhu.edu for future podcast episodes. Thank you for listening.